Hello, fellow problem solvers. So today we're going to be doing a problem from the Tournament of Towns from the fall of 2007, category Senior O, problem number 2. This is one of my favorite types of combinatorics problems because it epitomizes the principle of play. You need absolutely zero background knowledge, zero theory to be able to solve this problem. I mean, at minimum, some algebraic manipulations, how to add fractions together really. And for this problem, I would invite you to try it for a minimum of 30 minutes, ideally an hour and a half, but not more than 2.5 hours. If, on the other hand, you'd like to go along with us, I suggest a preliminary play and understanding of the problem for the next 10 minutes. So now, let's begin. So the problem says we have the numbers x, y, and 1 written on the blackboard, and at every step we can take two numbers from the blackboard and write their sum or difference on the blackboard, or we can take a non-zero number and write 1 over that number. The question asks, can we get to x squared and can we get to x times y? Now before we go that deeply into this, I want to point out that in these types of problems with parts A and B, you can sometimes, in some competitions, assume part A is true and prove B. If you can't prove part A, you can say, for part B, assume we've proved part A, now we're going to, and then use that fact to prove part B. So now, if you haven't already played, that's really the first thing you should be doing here. I'm just going to try to solve part A. Actually, wait a second. Let me do part B first. So let's assume we have A. Let's assume that from x, y, 1 we can get to x squared. Well, that means we'll have x squared and y squared on the board. So how do we get x times y? I invite you to take a minute to 5 minutes and figure out, once you have x, y, and you can generate squares of numbers that are on the board, how do you get x times y? And the answer is simpler than you would think. Like if you have x and y, you can get x plus y. Now because you have x plus y, you can get x plus y squared, which is x squared plus 2xy plus y squared. And now you can subtract from x, you can get 2xy plus y squared, and then you subtract y squared and you get 2xy. But this is twice of what we need. So how do we get half of this? Take 2 minutes to figure this out. And here's the thing. If either x or y is 0, then we've already have x times y. Assuming it's not, we can write the reciprocal. And we can write it twice. And then we take the two reciprocals, add them up. And what we get 1 over x times y. Now this is non-zero. We write the reciprocal of this. And we get x times y, and we are done with b. And I wanted to point out, again, like this is a totally legitimate partial credit for this problem. Like you should get full points for B if you assumed A was true and then solved B. Like without a doubt, at the IMO, 100%, I believe. But now let's go to the more difficult part, is how do we even get squares? Like we can't multiply numbers together. So how are we going to get squares from x, y, and 1? If you haven't played around with this, I suggest you pause for 10 minutes and play around and see what you would do. And here's the first principle. Let's ignore y at the beginning. Let's just say that we have x and 1 at the beginning on the board. And let's just do operations with these. Because here's the thing. Y is an extra thing. And it feels like we shouldn't really need to use another number to get x squared, because there's no other number. It's just x squared, but 1 could be useful. So now, what are the numbers we can get here? Well, we can get x plus 1, x minus 1, the negatives of these, and 1 over x. And now it's, again, a little bit of a play. How do you get, you can play around with it, like, really, and just, like, stumble upon it, where you can think, okay, how do I get squares? And what you may find, if you ask yourself, how do I get squares, is that you get squares by playing with reciprocals. Because when you have reciprocals, like, you get multiplying stuff. You're multiplying stuff together when you have reciprocals. So you have 2x and you have 2 as well. If I'm, like, adding, say, this, and the reciprocal of x minus 1, assuming x isn't 1, because if it is, we're done, what will I get? I'll get 2x minus 1 over x squared minus x. Like I will get a square that I didn't have before. So this is how we're going to be having squares. And here I would invite you to pause for about 5 to 15 minutes and see if you can get to x squared. And there's many ways to go about this. One is just, instead of adding, subtract 1 over x minus 1 over x. And what do we get? x goes here, x minus 1 goes here, they subtract, 1 is left, and we get x squared minus x. If x is 0 or 1, then this is 0. Otherwise, we are good, we're in the clear, we're just like having these reciprocals. And now we can take the reciprocal of this, and we have x squared minus x on the board. We add x to it, and we get x squared, and we're done. Now, if you wanted to write a solution for this, you would just need to state, assume x isn't equal to 0 or 1. If it is, we are done. We are done. We already have x squared. X squared is x, so we are good to go. And then we can actually apply all these operations. We can subtract these. We can have these two reciprocals, subtract them. This is non-zero. And then we can take the reciprocal of that and get this, add x, and get x squared, and we will be done. And a similar thing needs to be noted here, that x times y isn't 0. I think that's where, yeah, that's the only place where we're really taking the reciprocal. Or, yeah, otherwise we can get x and y squared. It doesn't matter if these are 0 or not. We'll get their squares. Now this solves our problem. And as always, thanks for problem solving.